Good morning all. Today we discuss part 4 from General Principles and Process of Isolation of Elements. In this part we explain metal refining. Metal refining, refining of metals, refining of crude metal. So refining is the process of removing impurities from the crude metal. For removing impurities from the crude metal, we can use different methods. First one, distillation. Second, liquation. Third, electrolytic refining. Fourth, zone refining. Then 5, vapor phase refining. Sixth is chromatography. And first one is distillation. Different methods can be used according to the nature of crude metal and the impurity present in the crude metal. We can use different methods. And first method is distillation. And here, this method can be used to refine the metals like zinc, mercury, etc. Here on heating the crude metal, the impurities evaporated to obtain the pure metal as distillate. Zinc, mercury, etc. can be purified using this method, distillation. And in this method, when the crude metal is heated, the impurities evaporated to obtain the pure metal as distillate. Clear? That is the first method. And the second is liquation. In this method, the metals like lead, tin, that means the metals having low melting point can be refined using this method, liquation. In this method, what we are doing is a metal rod of the crude metal is prepared, and the crude metal, the metal rod of this crude metal is placed in sloping surface, and therefore in this sloping surface high temperature is maintained, and the temperature should be above the melting point of the metal, and at this temperature the metal melts and it flows down through the sloping surface and it is received. And therefore, the impurity is left behind and the metal that is received at the bottom of the sloping surface. Clear? And that is liquation. And liquation is mainly used for the metals having low melting point, lead, zinc, etc. Liquation. Okay. Then third is electrolytic refining. Electrolytic refining means, in electrolytic refining, the process or the principle electrolysis is used. For conducting electrolysis, electrolytic cell is required, anode is present, cathode is present. Here, anode is the rod of crude metal. That means the metal to be purified is taken as anode, and the metal rod of the pure metal. Metal rod of the same metal, but it should be pure, and that will be taken as cathode. The impure metal rod acts as anode and pure metal of the same metal acts as cathode. And the electrolyte is the salt solution of the same metal. Let me give an example. For purifying crude copper metal, the impure copper metal acts as anode, the pure copper metal acts as cathode, and copper sulfate solution will be the electrolyte here. When electricity is passed, the reaction take place. You know, anode reaction, that is oxidation. Cathode reaction, that is reduction. Oxidation and reduction take place. Here, oxidation take place at anode, and as a result of oxidation, copper undergoes oxidation and form copper ions. And the copper ions move to the solution, and through the solution, it reaches to the cathode. And the cathode is the place where reduction takes place, and therefore this copper ion get reduced as copper and it is deposited at the cathode. Clear? Here oxidation takes place at anode, and the pure copper metal from anode undergo oxidation and it moves to the solution as copper ions, and copper ions move to the cathode, and cathode is the place where reduction takes place, and therefore at the cathode the reduction occurs, reduction of copper ions take place, and as a result copper ions reduced to copper and the copper metal is deposited at the cathode. And means as the time passes, the size of cathode increases. So here the size of anode decreases and here the cathode increases. And therefore, as the size of cathode increases, size of anode decreases. Here, from this crude metal, the pure metal moves to the solution and it deposited at the cathode. Here, oxidation take place. Anode is the place where oxidation take place. Cathode is the place where reduction take place. Okay. So, anode reaction, oxidation, copper. Here both anode and cathode copper. Therefore, copper undergoes oxidation, Cu2 plus 2 electron, and cathode reduction take place, Cu2 plus 2 electron gives Cu, and the copper is deposited at the cathode. And what about the impurities? The impurities collected or impurities will be settled at the bottom of the anode as anode mud. Okay. Hope all of you got clear idea about electrolytic refining. The principle behind electrolytic refining is electrolysis. And here metals can be electrolyzed and anode and cathode. Then electrolyte also prepared for electrolytic refining. Here copper can be refined by the process of electrolytic refining. Okay. Then fourth method is zone refining. Zone refining means this method of refining can be used to obtain high metals having high degree of purity. Semiconductors can be purified or semiconductors can be prepared by this method, zone refining. So, semiconductors require high purity, 100% purity. Therefore, in such a situation, we can refine the semiconductors like boron, then silicon, gallium, indium, etc. can be refined by the process of zone refining. And in this process, what we are doing is, we take the metal rod, metal rod is placed inside a heater and inside a furnace, and a heater is connected at one end of the crude metal rod. So, the heater is moved from one end to other end several times. In the same direction, the heater is moving from one end to other end, and therefore, several times the heater is moving from one end to other end in the same direction, and therefore, the pure metal crystallizes out, and the impure metal, that means the impurities, left behind at one end. Therefore, the pure metal can be cut off, and the impure metal, that means the pure metal is collected at one end and the impure metal is collected at another end. So, because the heater is moving from one end to other end continuously or several times in the same direction. Therefore, this pure metal present in this crude metal, that is crystallizes out, and the impurities present, crystallizes out means that is collected at one end, and the other end means only the impurities. Okay, so that is zone refining. So different zones. So metal from one zone to another zone. Metal enters from one zone to another zone. That is metal from its solid state to molten state. So, the pure metal is collected at one end, impure metal or impurities, not impure metal, pure metal is collected at one end, and the impurities remain at the other end. So, the impurity can be cut off very easily, and this method, zone refining, for if we need or if we require high degree purity metals, we can use zone refining. So, today in this part we discussed distillation, liquefaction, electrolytic refining and zone refining. Vapor phase refining and chromatography we will discuss in next part. Thank you.